seconds for YouTube to get caught up.
Okay, let me know. Oh, Tim's here.
Good.
Ray, you also hook, Alicia. You were going to have to give
it. I'm going to call this meeting into session. Hello, everyone. Welcome to the Los Angeles Astronomical Society General Meeting on April 12th, 2021. I am Alicia Hurst. I am the Vice President of this association. Our President Curtis is currently at Joshua Tree with one of our board members having a blast. So I'm going to take over for this meeting. First, right off the bat, I want to let you all know we will be using Zoom until the Griffith Observatory is open again. So look out for those links for Zoom meetings going forward for general meetings, and we'll announce when we go back to Griffith and open it up. To kick it off, I want to know, are there any new members or visitors that are joining us for this meeting for the first time?
I am. My name is Omar.
Hi, Omar. Why don't you tell us a little bit about yourself?
Hi, Omar.
Hello. Actually, I was supposed to be here at the last meeting. I didn't get a chance to make it, unfortunately. But I'm born and raised in Los Angeles. I'm a graphic designer, and I've always been, fascinated with astronomy. So I bought a telescope and I joined you guys, and I'm hoping to, try to learn as much as I can.
We'll see you soon. I like your moon background, Omar. That's cool.
Awesome. Thank you. I appreciate that.
Is
What kind of telescope?
I picked up an Orion Star Blast 90 millimeter. So it allows me to kind of carry it around. So I went to Joshua Tree and kind of started
grab
doing
and
my own
go.
thing a little bit. Yeah.
The best
it's nice.
scope is the one that
Absolutely.
you use. Yeah.
Yeah.
So welcome.
Thank you.
From over the hills and far away, Omar, welcome aboard.
All right,
too.
Thank you, guys.
My name is Len. I'm new as well.
Hi.
Welcome.
Hey, I'm in La Habra. Oops, that's my bird. I'm in La Habra.
I used to live in the Heights.
Yeah. I've always been interested in astronomy, but just been too busy with kids and stuff, and now they're all grown. So I'm empty nesting and trying to do my own thing.
Not quite empty.
No, I got this guy.
The nice thing about the Heights is it had no street lights.
Well, that's not the way it is now.
Okay, well, it's nice to meet you. Welcome to the club. We hope you were able to enjoy tonight and get to know the members as well. So yeah.
Thanks.
Okay. Are there any other new members, or are we good for tonight? I don't know.
Oh, also a new member here.
Yay! Hi.
Hey, Tyler.
Welcome aboard.
Tyler.
Hi, everyone.
Hi, Tyler.
Should I do a quick intro? Or
Yes,
You
please.
go for it. Yeah, exactly.
Cool. Sorry. So I just finished up my undergrad last year. I studied applied mathematics and astronomy, so very interested in theoretical astronomy, which is a little bit separated from observational telescope work, but trying to get into more observational stuff and outreach. So we're really excited to be here and to learn from all of you and to participate in this.
Okay, great. Congratulations
Welcome.
to you on recently graduating. So that's exciting. All right. Okay. So I think that's all the new members for today. So general announcements. We will have our in-person meetings. They will resume when the state of California, county and city officials issue the clearance to do so. We're also going to have the Lockwood Valley status from the Lockwood Committee Chairman. The Ford Observatory is closed until May. Hopefully by then the snow will have melted and it'll be safe to go there again. I really encourage the new members also to check out the Ford Observatory. It is an amazing experience. I had a blast there looking through the telescope, and the people who work on it are really nice and cool. And Curtis is one of the people, as well as Joe. When we give the meeting presentation, when Tim gives his presentation, we're going to have everyone muted when he starts to make sure that there's no interruptions, and you can save your questions until the end of the presentation. That would be appreciated. And we'll just go through it afterwards. So I'm going to turn the floor over to the Lockwood Valley Community Chairman, John O'Brien. Is he here tonight?
I don't see him.
You don't see him?
Apparently not. It's Mike Hayford here.
Actually, I
Oh,
am.
go ahead.
There he is.
Oh, there you go.
Where are you?
I'm here by
All
Los
right.
Angeles.
Well, do you want me to introduce you, Mike? This is
sure, why
Kevin
not?
speaking. All right. Well, this is Kevin Gilchrist talking. I am now one of the former Lockwood co-chairs, along with John O'Brien, who apparently is not online tonight. But I'm moving from the Los Angeles area, and one of the requirements of being on Lockwood Committee chairperson is actually being able to be on site and things. So I'd like to introduce Mike Hayford, who is graciously taken up my position. And although I will stay on and do as much as I can through Zoom and whatever else they need me for, and maybe, well, it's not that much of a drive from Kingman. It's about a 6-hour drive to LA. But take it away, Mike.
All right. Well, we've, as people probably are aware, we haven't been able to have Lockwood open for the general membership, our family nights or dark sky nights, because of the state requirements on people assembling, outside of their family units, if you will. And Ventura County, as of, I believe, the 15th, will be coming into the orange zone. And that will allow outdoor gatherings of up to 100 people, I believe, to take place. Our normal dark sky night is on usually the third quarter, the closest to a third quarter, third quarter moon, and so the next one by that measure would be probably Saturday, May 1st. We could open it up potentially this Saturday, but it's really close to a first quarter moon. The moon is not going to set until almost 1 in the morning. So, if people want to, if people want to advocate for, having a partially dark sky night this coming Saturday, please, send email to the group's IO list and advocate for that. But if things remain the way they have been, there aren't any other state-related issues, it looks like the first time we'll be able to open for membership would be basically May 1st, the first Saturday in May, and that would be like a third quarter moon. What we've been doing is we've been, the site has been open for STAR members, and they're required every time they go up there to sign an online waiver that says, yes, they do not have the various COVID symptoms. They will obey all the social distancing and wearing masks and that sort of thing that the state mandates. And I think for the dark sky nights, we'll also require people to at least sign the waiver saying that they take the responsibility and the risk of attending this. Basically, the insurance that we have on the property, the liability insurance, the carrier was very explicit last year saying that the insurance does not cover any COVID claims. So this is why we've been so maybe officious or not very flexible on this, is because it is a serious pandemic, and if people attended and got sick and they traced it back to us, it could be bad for a variety of, for many different reasons. So, so I think our first dark sky night, fingers crossed, and everything staying the same, will be May 1st on Saturday, and we'll have a we'll send a link out for the waiver of people to sign, and we'll limit it at 100 people, which would be a tremendous turnout, but just to ensure that we are within the within the state requirements. So that's, I think, good news, is that we're finally, and the timing is right too, because it's now becoming rather temperate up there, as opposed to visiting
Has the snow melted
January,
yet, Mike?
The snow is gone, apparently. And you don't have to have chains to get to the site. So the relaxation of the guidelines is coming at the right time of year for us. So
and actually looking at the temperature, it's been below 32 degrees for several nights, several weekends now.
Yeah, it does get nippy up there.
Mm-hmm.
Even in it is at 5,000 plus feet altitude. So even in the summertime, it doesn't get down to freezing, but it can get chilly. It's not shirt sleeve temperature necessarily.
You'll
even
need
in the
your club
summertime.
jacket, right?
Exactly.
Ordered from our new website, of course.
Of course.
If I may just add a couple of little details to Mike's announcement. If you go to laas.org and look at our calendar, May 8th is scheduled for the official dark sky night, and we were actually thinking about sticking in a second one just out of celebration. And that would be the May 1st, if indeed we go ahead and do that. But we haven't actually discussed it amongst the board yet, but we'll do that soon.
Hey, yeah, go ahead. The question's in chat, right?
Yeah, I was about to bring that
Yes.
up. Right.
Okay, go ahead, Alicia.
Oh, Jeff had a question in chat, and I was going to bring that up, but it sounds like Tim or Greg was going to do that too. He was asking, does the fact that one has a vaccination completed card help? He knows it's not science yet as to whether that means you cannot transmit the virus.
We're basically going by the state requirements for opening the facilities, and if to my knowledge, the state requirements say nothing about whether you have vaccines or not.
Okay.
I think in general, it's a really good thing to have your vaccinations. So we encourage that, because that not only reduces your risk of going to a gathering, even outdoors, but it also it reduces the community's risk. So there's nothing that I'm aware of in the state guidelines that says things about opening, requiring, or changing the parameters if people have vaccinations. But so that's kind of what we're going on.
I believe the guidelines are that if you can demonstrate that everybody attending a function is vaccinated, then you can increase the number beyond 100 people. But that's the only thing I've seen in the guidelines that refer to vaccinations.
Yeah. I can say that 100 people at Lockwood, it would be very crowded.
Yeah.
That's a lot of people. I mean, 60, it's starting to be noticeably full. 45 is usually 45, 50 is often been kind of the maximum number of people who we've had up there on head counts.
Okay.
Well, the sky up there is beautiful. I'm looking forward to May or June or whenever we can get back up there and be a club again. look through our telescopes.
Agreed. Okay, so thank you, Mike, and thank you, Kevin, for that committee report. Really appreciate it. Hopefully that answers a lot of questions that some of the membership had about it. Now I want to turn the floor over to Spencer so he can talk about the door prize entry link and also introduce our speaker for the evening,
All right,
as well as the guidelines for asking questions.
All right, so yeah, if you look at the chat, you see I've posted a link for the door prizes. So at the end of the speaker's talk, we'll have a drawing for door prizes, and it'll just be, we'll fill out the form. We'll get your name and email addresses, and we'll make a drawing from who signed in or who registered. There's been a change in the guest speaker. David, the speaker could not make it. We got an email from him about 15 minutes before the meeting saying he was having computer problems and he wasn't going to be able to join. So Tim Thompson, I caught him as he was on his walk, and he graciously agreed to present. I think it'll be an interesting talk. Tim, what's the title of your talk?
Well, what I thought I would do is that Curtis wanted me, if there was an emergency last month, because it was National Women's Month, give my talk on women in science with some emphasis on astronomy. And so I thought I would do that. I mean, if people want me to talk about something else, I suppose I can invent something on the fly, but that's kind of what I thought would be the easiest thing to do. Elizabeth obviously likes the idea.
I think it's a fantastic idea. You need more women in STEM.
Yeah. All right. Oh, I'm sorry. I see a note from Greg saying he has an update. So, but let me before we leave the speakers, and then we go to Tim. So I think the rules for the guest speaker are that I'll mute everybody, and so hold your questions until after the speaker's finished, or you can post them in the chat. So then after the speaker's finished, I'll go ahead and unmute people, and you can ask questions. At the same time, we'll read the questions that were in the chat, and you can answer them. So, and then again, like I said, there's a link for the door prizes, so go ahead and please register for that. Okay, so that's all I had, I think. So, Greg, you had something?
Just real quick. So this is Greg Thompson. I'm on the board, and I've for the last couple of years been running our outreach program with scouting, and the last couple of I guess now 3 years we've had our astronomy merit badge class. In 2020 we went all virtual, and we continue to do what events we can through the virtual forum of Zoom provided by the club. And last month we had a Cub Scout pack that we did an astronomy outreach virtualized with. And so outreach isn't completely dead. We had 60 scouts and over 100 people in attendance. The 3 club members shared their telescopes live through the virtual session, which makes it, a little more exciting than just, a lecture, especially for the younger Cub Scouts. Anyway, it was a big hit. We got a lot of great feedback, and we are looking forward to our summer program. Probably in June, we'll be doing a virtual merit badge class, but we're very hopeful in July and August, we'll be back at Garvey Ranch in the classroom and the observatory, and there will be some opportunities for club members to join in and share their telescopes or participate in those programs. I think I'm going to have some opportunities for some summer camp outreach in July and August at Circle X up by Lake Arrowhead. And so we haven't been completely down. And I just want people to be aware that we're still trying to fulfill our club mission through these trying times. I'll try and get some of the pictures and an update in the bulletin so people will know what's going on. If anyone has any questions about these elements of our outreach program, feel free to contact me. I know we're still looking at when and how our general outreach program with LAUSD is going to be back up and running. Keep an eye on the email and our club calendar for updates. I'm sure there'll be some communications coming out in the coming months on that. And I think we're going to try and put together a astrophotography panel discussion in the next month or so. And we'll be getting the links and calendar entries out for that. So I just want people to know that we're still alive and going and doing our thing, even with just the virtual platform available to us. So thanks a lot for the time. Appreciate it.
Good job. Thank you. It's nice to see Tom here tonight, by the way.
Guys.
Yeah.
All right.
Well, are we ready?
I think we're ready.
Pick it off.
Go ahead,
Tim.
Alicia.
All right. Let me stop
Okay.
sharing. Okay. All right. Oh, I guess I should.
will.
Okay, Tim, want to
Yeah.
introduce yourself to the new members?
Well, most of the people here probably have already seen me once or twice over the last 30 years or so. My name is right there on the little window, Tim Thompson. I've been president of the LAAS several times. I'm now on the board of directors, and I'm a retired physicist. Worked at JPL, astronomy, atmospheres, all kinds of stuff. And I do a lot of public speaking like this. And last month, when I was attending the Palomar Greenway talk, their speaker also did not show up, only did not announce that they weren't showing up. They just didn't show up because the alarm didn't go off and tell them they were supposed to give a talk. So I wound up helping them too. So I guess the worst thing you can do is have me scheduled to attend your talk, because then something will go wrong and I'll have to clean up the mess. So here I am. And I guess, can I share my screen?
Sure, go ahead.
Let me, there. That ought to have shared.
Okay, we see it.
There. Hopefully everybody can see my screen.
Yeah, we can.
Good. I can't see the full width of all my slides because the talking heads of the talking heads of Zoom cover up some of them. So we'll see how this goes. So I'm talking about women in astronomy science, and really I don't talk too much about what you consider contemporary women. Most of them are not in my talks, because what I'm trying to do is kind of set the stage, talk about women through history who have, say, cleared the way for other women today. There are a lot more women in science now than there used to be, and a lot more prominent women. There have always been more women in science than you would think, but they were all not prominent and they were all hidden away. And so here on my title slide, you see the covers of 3 particularly interesting books. The Rise of the Rocket Girls and Hidden Figures talk about the JPL and the NASA computers were almost all women. The reason electronic computers were called electronic when they first came out, because computer was a job title for a person, most of them being women, occasionally men, but most of them women. And the book in the middle, The Glass Universe, is the story of the Harvard computers, who were all women by design. And it's a really interesting book. And they were turn of the century, around the late 1800s, early 1900s. And a really fascinating collection of women. I'll talk about some of them during the course of my talk. And so these are books that are worth looking into if you're interested in this kind of topic. And there's a few more that have been done since then that I haven't had a time to. If I'd known a few days in advance I was going to do this, I would have had time to, jiggle some slides. But you're stuck with what I've got. So
Tim, you muted yourself.
I didn't mute myself, I don't think, but I got muted somehow.
You're back on.
Now I should be unmuted.
Yeah, you're on.
Oh boy, I don't know how that happened. Anyway, you look through ancient philosophy, there's a pretty consistent connection between women, or maybe femininity, and science. Maybe scientists weren't considered real men or something, I don't know. But I have a couple of diagrams here to illustrate that. The one on the right comes from an old illustration of Euclid's Elements during the 1300s, where geometry is kind of displayed as a woman. And the ticket to the Leverrian collection over the left, it's an art museum or science museum in London during the late 1700s. And the ticket to get in has this old diagram: as Father Time reveals the truth, it's the woman who shines the light on it. And I put this on here because while there is such a strong connection or allegorical connection between women and science in philosophy, when it came to the real women, that connection was kind of forgotten most of the time. Whoops. So Elena Pisk was the first woman ever to receive a doctoral degree in this modern sense of the university offering a degree in 1678 from University of Padua in Italy. And I think you'll find during the course of the talk that generally speaking, the Italians, they don't really have a problem with smart women. They're fine in Italy. French, on the other hand, they didn't really go for that kind of thing very well. And the Brits, yeah, they're kind of half and half. And I haven't had a chance to modify this. Juliana Morel has a long reputation for having received a Doctor of Law degree, actually from the Pope in 1608. But a re-examination of the historical record has demonstrated that, in fact, she didn't. And while she was offered a degree, she declined and didn't want one, so she could run off and hide in a convent for the rest of her life, is what she did. So she actually did not get the degree that she's credited for here. But Piscopia did, and she's the first. Maria Kunitz is interesting because she, like most of the women I'll talk about, she was self-taught in mathematics. She corrected the mistakes made by Johannes Kepler in his tables for looking up the positions of planets. And she simplified. He was using logarithms in a cumbersome way. She simplified the way he did his mathematics. But of particular interest, she translated his work from Latin to German. And she wrote some of the very first science in the German language. The Germans are good at that. They'll have words that are longer than a mile. They're almost as bad as the Welsh. The Welsh are the worst. But the Germans are right up there with them. They got words that they take 5, 10 words, slam them together, and make one word out of them. So she made up a lot of that. So a lot of the modern German scientific terminology has its roots in what Maria Kunitz did. Of course, you've never heard of Maria Kunitz, but she was well known at the time in Central Europe. Gabrielle du Chatelier is a really interesting person. She too was self-taught, although her father made sure that she learned a lot of mathematics and philosophy as a kid. She translated the 3rd edition of Newton's Principia into French from Latin, because Newton wrote it in Latin. And that is, to this day, the standard translation from French, from Latin into French for Newton. Nobody's done a better job, or tried to, I guess, since then. Somebody's probably tried, but they haven't done a better job. She was a very talented mathematician, linguist. She's one of the first to suggest what we would now call the conservation of energy. At the time, Newton was inventing calculus and inventing physics, there was really a discussion over whether forces or energy were fundamental. And Newton actually tended to think in forces, not energy. And it was Leibniz who thought in terms of what we would now call energy, although he wrote it down differently. Whole concept of energy was pretty dodgy for a long time. And so she was one of the first to really put it on a solid footing. But being a woman, while all the French scientists knew her, they were, of course, not, although she did publish a paper for the Academy under her own name. She was a very close friend, an intimate friend of the French philosopher Voltaire, who called her a great man whose only fault was being a woman. And she was not admitted to the French Academy of Sciences to membership. They did not let anybody into like 1960s, any women at all. And the only women who could come into the room were the wives of the members of the committee. Otherwise, you couldn't get in. And she became quite frustrated with this because they all knew who she was. They wouldn't let her in. So she showed up one day dressed as a man, and they all got the hint and kind of looked the other way. And she went and sat down. That's how she bullied her way into the meetings of the French Academy, even though they never made her a member. She at least got into the room. She was one of the founders, really, of modern French science. Now, remember, the Italians, they didn't really have a problem here. Laura Bossie was the first to receive a doctoral degree after Elena Pisk, about 54 years later, and was elected professor of anatomy. And she taught men, which was really scandalous and kind of a big deal in the history of women in science, to actually teach science to men who, if they could stand the indignity of allowing themselves to be taught by a woman. And one of the things she specialized in, aside from Newtonian physics, I have here Franklinian electricity. Most Americans don't appreciate the exceptional international reputation that Benjamin Franklin had as a scientist. And he was a pioneer in studying electricity and electromagnetism. Electricity, really. The word battery is a word that was invented by Franklin because a row of Leyden jars remind him of a row of cannons, a battery of artillery. So he called it a battery, and it stuck. So Franklinian electricity was a real topic during the late 1700s, early 1800s. Maria Agnesi was appointed a professor of mathematics also at the University of Bologna. She was the second woman after Laura to hold a university faculty position, although it's not evident that she actually taught. And she was the first woman professor of mathematics. She also wrote the first textbook, as far as I know, that discussed both integral and differential calculus altogether. And if you're a mathematician and you've ever heard of an oddball curve called the Witch of Agnesi, it's named after Agnesi here, not because she was a witch, but because, as often happens in the history of science, somebody mistranslated an Italian word that meant something else. So, oh, this means witch. We'll call it the Witch of Agnesi. And so it stuck, and there you are. So Caroline Herschel is somebody you should have heard of. She was Frederick William Herschel's sister. And they had an interesting, complicated relationship, especially after her brother got married and his wife took over the duties of running the household, which kind of undercut Caroline's social status. She was single and she was short and not considered attractive enough to catch a husband. But she worked for a long time as her brother's assistant, discovered a comet, and eventually was granted a pension of £50 a year, by King George III, same guy we revolted against a few years before, which makes her the first woman ever to be paid to do scientific work. Now, under her on the slide is Mary Fairfax Somerville, she was really well known. She translated Laplace's 5 volumes on celestial mechanics from French to English, and as she says, she translated his mathematics into common language. What Laplace had done is modernize it, especially to look at orbits, since celestial mechanics is the title. And she speculated in one of her books that maybe Uranus moves funny because there's another planet pushing it around. And her book provoked John Couch Adams into looking for and predicting a position for Neptune. Of course, Leverrier gets credit for finding it because Adams never told anybody what he was doing, and Leverrier did. And of course, his own French Academy laughed at him, so he had to find a German astronomer to go find it for him, and it all worked out. Caroline and Mary were elected members of the Royal Astronomical Society at the same time in 1835, and sources differ on whether or not they were elected honorary members or full members. So I don't know which one it actually was. And I should add that the word scientist was actually invented by an English philosopher named Whewell to be similar to the word artist. He said, well, if people who do art are artists, people who do science must be scientists. And he invented that word specifically to describe Mary Somerville. So if you want to know where the word scientist comes from in the English language, it comes from Whewell talking about Somerville. Mary Anning, aside from the unfortunate fact that she was a woman, also declined to join the Anglican Church. And there's a word for that I can't remember in English, but anyway, being both a woman and an Anglican really turned out kind of bad for her. She was a fossil hunter and a very successful one, found the first full ichthyosaurus and pterosaur fossils, numerous fish fossils. She's well known by the men in the Geological Society of London, excuse me, partly because she was a woman and maybe mostly because she was not Anglican. And it was bad enough for her that there were even members of the Geological Society who were taking credit for her discoveries, even though they knew her and they knew she's the one who discovered them, but they basically ignored her. And she died more or less in poverty and unrecognized and unwelcome, despite the fact that she was a very successful paleontologist. And then many years later, in the 2000s, I think, Mary Anning was judged one of the 10 most influential women in the history of British science. So she's been rehabilitated in modern times, but in her own day, not so much. But she did sell seashells by the seashore, and the tongue twister, she sells seashells by the seashore, was in fact written to describe Mary Anning. So if you want to know where that comes from, there she is. Ada King was the legitimate child, evidently the only legitimate child, of the poet Lord Byron, who abandoned Ada and her mother when she was very young. So Ada's mother became convinced that poetry had driven Lord Byron mad, and she was not going to allow her daughter to learn poetry and literature the way women usually did in those days. She made sure that Ada was schooled in mathematics and philosophy and science. And so she was part self-taught and part tutored. And in fact, one of her tutors was Mary Fairfax Somerville, whom we saw on an earlier slide. And one of her social friends was Charles Babbage, who invented the first analog mechanical computers with gear wheels and levers and flippy things. Well, she wrote, she took an Italian article that had been written describing his analytical engine, which had never been built and never was. He built a smaller difference engine, but he never built the big analytical engine. She took this article, translated it from Italian to English, and tripled it in size with all her notes and comments. And one of the things she did was she wrote down an algorithm describing how you would compute the Bernoulli numbers using the analytical engine built, not built, but designed by Babbage. We know now, because people have finally designed digital analogs or built mechanical models, that in fact it would have worked had he built the analytical Bernoulli numbers, which are one of these peculiar numerical sequences that come out of something like a Taylor series in calculus. So she had to know how to calculate them. So she is recognized as the world's first computer programmer, and maybe the world's first computer scientist. She didn't just write a program, she designed the algorithm for it. So if you work with computers, one of the reasons is Ada. She's one of the first. Yeah, I see that. Maria Mitchell was the first American professional astronomer. She was a Quaker. She discovered a comet in 1847, and of course, a woman discovered a comet, so she became instantly famous. Denmark gave her a gold medal, and she had an international reputation, so she got on the faculty at Vassar College, which made her the first faculty member at Vassar. And there's a picture of her first astronomy class around 1865 or so. That's, of course, Maria on the left. She had quite a number of firsts to her credit. First elected Fellow of the American Academy of Arts and Sciences, first elected Fellow of the American Association for the Advancement of Science, first woman professional astronomer in the United States, and et cetera, et cetera. But perhaps most interesting, champion of equal pay for women faculty members. Maria discovered that men working for her and under her supervision were earning more money than she was. So she complained, and the faculty didn't really buy her complaints, and they went back and forth and had some arguments, and she threatened to quit. Well, by this time, she had an international reputation. She's very well known and would not have had much trouble finding a job somewhere else. And the Vassar College faculty got scared. Maybe she really would quit. And so they cut a deal with her, and she got a little more pay and some perks from the university. And so one of the reasons women managed to make a little bit more money in science in general probably was Maria Mitchell fighting with the faculty at Vassar College. Sarah Whiting was the first woman professor of physics. Now, she was a teacher at Wellesley College, and Edward Pickering invited her to come and study at Harvard, the Harvard College Observatory. She couldn't take any real classes because they wouldn't let women into the classes, but she could sit there and learn without really taking the class. And several of the women computers in the Harvard computers learned physics actually from Whiting at Wellesley College. And there's a quote here from Annie Cannon, who was one of the Harvard computers, in the obituary that she wrote for Sarah Whiting. And I think I can read most of it. An especially exciting moment came when the Boston morning papers reported the discovery of the Röntgen or X-rays in 1895. The advanced students in physics in those days will always remember the zeal with which Miss Whiting immediately set up an old Crookes tube and the delight when she actually obtained some of the very first photographs taken in this country of coins within a purse and bones within flesh. And here are the Harvard computers. Williamina Fleming was the first. And so as the story goes, and it's probably true, but if it isn't, it should be, in charge of Harvard College Observatory, had taken on the task of creating the Draper spectral catalog of images made by Henry Draper. His techniques would only allow him to photograph one spectrum at a time, but Pickering and others had figured out ways to use wide-angle lenses with diffraction gratings and get many spectra on a single image. And so they had lots and lots of spectra to catalog, and he needed to get cracking. And he was unhappy with the performance of his men doing the job. And he got mad at them and he yelled at them and said, "My housekeeper can do a better job than you do." And then he went home, got his housekeeper, Williamina Fleming, told her what she needed to do, taught her how to do it. In a few days, she was doing it. He was happy with her, so he fired everybody except Williamina and left her to hire all the computers she wanted. Not surprisingly, Williamina hired women, all women, which not bother Pickering. He didn't really care whether the computers were men or women, but he was able to pay women less than he would pay men, and he was on a stretched budget. So not surprisingly, he was very happy to have lots of women computers so he could pay them just a little bit less than he would pay the men and scrape those pennies. So Williamina was in charge, and she's pictured here. She's the one who discovered the Horsehead Nebula. So for you Horsehead Nebula fans, she's the one who found it on a photographic plate. Antonia Mori and Annie Cannon created what's now called the Harvard Spectral Classification System for stars. And I think I have a slide of Annie and Henrietta Leavitt coming up. Henrietta, of course, discovered the period luminosity relationship for Cepheid class variable stars. And Cecilia Payne, she's the one who wrote what might be the most brilliant PhD thesis in astrophysics. She's the one who discovered that stars are made out of hydrogen and helium. Prior to Cecilia, nobody knew what stars were made out of. Nobody knew what stars worked if they were big and hot. And the assumption was they were made out of the same stuff as the Earth, hot dirt, silicon, heavy metals. But Cecilia was the first to apply the new science of quantum mechanics and the Bohr atom to stellar atmospheres. She followed the lead of an Indian physicist named Meghnad Saha. And when she went through all the calculations, she realized that the reason there's a huge number of iron lines in the solar spectrum is not because there's more iron, it's because there are more ionization states for iron because it has so many electrons. There's a lot more electron states available and therefore more spectral line. And she went through all the strengths and everything, realized, oh, it's all hydrogen and helium. And everybody laughed at her, and her thesis advisor said, "You can't say that. I'm not going to give you a PhD for that." But then she gave her a PhD, but she had to write in the thesis that this is probably wrong because everybody knows it doesn't make any sense. And then by about 5 years later, everybody figured out that it wasn't wrong and did make sense and it was right. And so Henry Norris Russell, who was her advisor, wrote a paper in 1929 about the same thing. And he did acknowledge Cecilia in the paper, but kind of quietly. And so there are a lot of people around still who think it was Russell, who's very famous, who made that discovery. But in fact, it was Cecilia Payne, who became famous under the name Cecilia Payne Gaposchkin after she married a Russian astrophysicist named Gaposchkin. And this is Henrietta Leavitt. She made was probably the greatest discovery in astrophysics and cosmology, certainly one of the most fundamental discoveries, and that's the period-luminosity relationship for Cepheid class variable stars. She was looking at the Small Magellanic Cloud, and in 1908, she published a paper about the variable stars, and she made a comment that it looks like there's something funny going on here, like that there's a relationship. It looks to me like there's a relationship. And then she studied it, and in 1912, she wrote a paper describing in detail what was going on and describing the period-luminosity relationship. She was the second author on the paper. Edward Pickering was the lead author, as I recall. And Pickering wrote the first sentence of the paper, and it's the only part of the paper he wrote. And basically the first sentence says, "Hi, I'm Edward. Everything after this sentence was written by Miss Leavitt." And that's it. But woman, you know, she couldn't publish a paper on her own. She had to have a man's name on the paper, and Pickering was the boss. So I put his name on the paper, but first sentence of the paper was, okay, worked out pretty well. The period-luminosity relationship for Cepheids is the tool that Edwin Hubble used to discover the distance to galaxies, worked on the expansion of the universe. It's the tool that Harlow Shapley used at Mount Wilson to discover the Milky Way galaxy with a 60-inch. It's really a very big deal. And the fundamental tool still used today to describe intergalactic distances. Edwin Hubble, who was actually unhappy with the fact that he didn't get a Nobel Prize, which he thought he deserved, also thought that Henrietta Leavitt should get a Nobel Prize. So a Swedish mathematician named Mittag Leffler decided to nominate her, but she was had already passed away from cancer by the time he decided to nominate her. And so that didn't go anywhere. They never award Nobel Prizes. Pass you the prize and then you die, then they will award it to you, but otherwise no posthumous Nobel Prizes. That's why she didn't get a Nobel Prize in physics, but she deserved one. Maybe Hubble did too, who knows. And this is the plots from her 1912 paper, the one where she really says what's going on here. And if I can put my little arrow up here, this is a linear plot. So this is magnitude here, apparent magnitude. And this is the period. The horizontal is the period in days. And what she noticed was that the longer periods get brighter. Over here on the logarithmic plot, again, it's linear in magnitude up here, apparent magnitude, but logarithm of the period in days, so that you can plot a line because it's a logarithmic curve. You can see there's a lot of scatter in the data, but at minimum and at maximum, it appears that the brightness of the star depends on the period. She didn't know how far away they were, but Einar Hertzsprung calibrated this relationship in 1913. So she published it in 1912. He calibrated it using statistical parallax in 1913. Then in 1914, Harlow Shapley was running away with it, working at the 60-inch telescope, trying to figure out cosmic distances using her discovery. Very important discovery. And okay, that's the way we write down the formula. I won't go into that too much. That's how we use this relationship. Annie Cannon, she got her degree under Sarah Whiting. She used photographic plates and a magnifying glass, and she's the one who did the spectral classification system. And she probably looked at about 500,000 individual star spectra on the little glass plates, discovered a bunch of variable stars, nova, and a spectroscopic binary on the way. But probably nobody will ever look at as many stellar spectra with their eyeballs as she did. And she was able to classify 3 stars per minute. But computers do that now. People don't do it at all. So nobody's going to sit there and stare at 500,000 spectra the way she did, unless they just want to make a point or something. The spectral classification that we now use for stars, the O, B, A, G, F, K, M, etc., was her invention. Williamina Fleming had a shot at it. Antonia Maury took a shot at it. I think maybe even Pickering did, but they finally gave it to Annie Cannon, and she's the one who turned it into the classification scheme we use today. So when you talk about the spectral class of a star, Annie Cannon is the one who invented that idea. And here is the classification. Hey, I remember them in the right order: O, B, A, F, G, K, M. Antonia Maury had it first, and it's a system that came from Angelo Secchi in Italy. And it's interesting because Antonia Maury's uncle was a famous naval officer who was a director of the Naval Observatory, and he was a good, close buddy of Angelo Secchi. So there's a family connection between her and Secchi, but it was Cannon who finished it off. And there's Cecilia Payne, who became famous, as I already said, for her discovery that stars are made out of hydrogen and helium. Marie Curie is an interesting character. She received the Nobel Prize in Physics in 1903. She shared with her husband. The Nobel Committee originally awarded the prize to her husband and not to her. And only after he actually went to Sweden, I think it's Sweden, and argued with the Nobel Committee describing how they worked together, did they then split the prize between the two of them. He had to personally interfere to get her half of the Nobel Prize in Physics. And she was the sole recipient of the Nobel Prize in Chemistry in 1911. Her daughter was also a Nobel Prize in Chemistry. So there are 5 Nobel Prizes in the Curie family, because Marie got 2, her husband Pierre got 1, and Irene and her husband both shared the same prize. Interestingly, Marie Curie, after a very acrimonious debate, was denied a place in the French Academy of Sciences, even after she had won 2 Nobel Prizes, one in physics and one in chemistry. The French Academy still refused to allow her to be a member. And the excuse they gave, and it's a pretty thin excuse, was that she was actually Polish and born in Poland, so they weren't going to let her in. All of the National Academy of Sciences have foreign members. It's routine, it's common. It was routine and common in that day. And everybody with half a brain would see through an excuse like that. They just didn't want to make a woman a member of the French Academy and didn't until 1962. And the woman whose name I forget now that they did admit was one of Marie Curie's graduate students. So maybe in proxy, she got in. Emmy Nether was a mathematician, and she's the one who came up with Nether's theorem from the calculus of variations, crucial in theoretical physics. She proved that when you have a symmetry in a physical system, that implies there is a conserved quantity. And it's the mathematical, the theoretical justification for conservation of energy in physics. You think energy should be conserved, and observationally you see that it is conserved, but you can't prove it. There's no theory until Nether comes along And Nether's theorem is probably the most important of all the theorems in mathematical physics for its effect on conservation laws in physics. And I kind of like the fact that her father was the doctoral advisor for a mathematician named Emanuel Lasker, who just happened to be world chess champion for a long time. But Lasker came up with a new theorem in algebra, which he proved for a special case for rings, which is a special kind of field in mathematics. And Emmy took it and generalized it. And the reason rings became a big deal in mathematics is because Emmy generalized Emanuel Lasker's theorem. And since I like Emanuel Lasker, I like to point out that he was more important for things other than just being world chess champion for 27 years. Now, Lisa Meitner, she's the one who discovered nuclear fission. So she ran away from Germany as the Nazis became powerful and was in Sweden. Her friend and mentor and laboratory colleague, Otto Hahn, was still in Germany doing experiments, and he discovered something very strange, I think beryllium nuclei suddenly showing up out of nowhere in his experiments. He didn't really understand, so he asked his friend Lisa to figure out an explanation if she could, and she did, and she figured out that what was happening was nuclear fission. But when the Nobel Prize in chemistry was given out for that, it was given solely to Hahn, was not given, shared with Meitner, even though she's the one who figured it out. This is one of those famous examples of women who really didn't get credit for what they had discovered. And there's a lot of examples of Nobel Prizes, men and women, who were not given out to people who really deserved a chunk of the prize. In this case, if it created any friction between Meitner and Hahn, it never showed, and Hahn never mentioned it. They were very close friends for the rest of her life. But there was one instance, and I can't remember the names, of two men, one of whom received a Nobel Prize, was so mad that they didn't give it to his laboratory assistant that he split the prize with him anyway. There's a lot of examples of that in the Nobel business. Maria Geppert-Meyer shared the Nobel Prize in Physics in 1963. And no one had won the Nobel Prize since Marie Curie, no woman. She actually did get it for her work in nuclear physics and modeling nuclei. It's called the shell structure model for atomic nuclei. And I like this picture because she's holding this very strange ancient device in her hands that you might think is one of those ancient religious symbols. But back in the old days, those of us who can remember used to use those things to make calculations and slide rule. And that's what brought Apollo 13 back in one piece, was the slide rule. And of course, young people these days, they're used to their electronic calculators. Battery never runs out in the slide rule. And so at the time, Maria was only the second woman to win a Nobel Prize in physics. And so I've always thought, well, you can't win the Nobel Prize unless your name is Marie or Maria or something. But of late, there have been some women, Andrea Ghez is one, who've won the Nobel Prize in physics lately. So it's gotten a little bit better for women. Now, I think there are 4 or 5 Nobel laureates in physics. It's small percentages. Dorothy Crowfoot Hodgkin was the recipient of the 1964 Nobel Prize in Chemistry for her work in X-ray techniques and the structures of important biochemical, molecules. And she really pioneered the application of X-ray crystallography to biological molecules. she's interesting not only for her own accomplishments, but one of her students, a woman named Margaret Roberts, who later became famous as Margaret Thatcher, the Prime Minister of England, the longest serving woman Prime Minister, maybe the longest serving Prime Minister, period, long time. Well, Margaret Thatcher had an honors degree in chemistry, which she earned under Hodgkin, doing X-ray crystallography on biomolecules. I forget which molecule, an antibiotic named gramicidin D. Complicated chains of molecules, a difficult task. And so that's Margaret Thatcher on the bottom picture there, back in the days when she was kind of a scientist, chemist. She did some food specialty. She worked on improving ice cream recipes. So there's a rumor going around that soft serve ice cream was the invention of Margaret Thatcher, which is not really true. But she did work on ice cream aside from her more important work in biomolecules. So Margaret Thatcher, famous politician, famous for leading the British, actually had an honors degree in chemistry and was herself a legitimate scientist. Maybe someday we in this country will be able to say that about our leaders. just opinionating for a moment. Vera Rubin, she originally applied to Princeton University, but Princeton would not allow women into their graduate astronomy program until 1975. But I don't think it was a great enlightenment. In 1975, several federal anti-discrimination laws were passed, and I suspect they were forced by law to admit women, and maybe they wouldn't have even after that. So she went to Cornell and Georgetown University. She's the one who, say in the modern sense of the word, discovered dark matter. She was looking at the rotation of galaxies, and if the matter that we see was all the matter that was there, you would expect the outskirts of the galaxy to be rotating more slowly. Kepler's laws, you'd expect to see Keplerian rotation, but you don't. The galaxies, as you go out from the center, rotate pretty much at a constant linear type velocity, much faster than they should, which implies a lot more mass distributed in there, which implies the presence of dark matter. This idea had actually already occurred to Fritz Zwicky back in the 1930s and occurred to Jan Oort in about the same time, but they didn't catch much traction. Nobody paid much attention. And anyway, in those days, it would have been easy to hide the dark matter in red dwarf stars, gas, dust, planets, all kinds of stuff they couldn't see. But Vera Rubin did her work looking at radio emission from hydrogen, the 21 centimeter line. So she was seeing gas and she was seeing the dust. And of course, in modern dark matter studies, we can see it all, and we're much more confident these days in our knowledge of dark matter. But she's the one who kicked it into attention-getting mode with her work on galaxy rotation curves. Henrietta Swope was an astronomer and inherited a lot of money from her father. She's one of the very few rich astronomers. And aside from her own research in astronomy, she donated the money that built the 1 meter Henrietta Swope telescope in Los Campanas observatories. And in 2017, when the LIGO gravitational wave observatory saw its first neutron star merger, it was Henrietta Swope's telescope that was used to discover the optical counterpart. And with that study, people were able to look and see, is this how you make gold? Which it is. They could see heavy elements being formed. So first observe neutron star mergers. There's a lot to learn about neutron stars and that kind of stuff. And so it was her telescope. One of my favorites is Amazing Grace Hopper, who, just looking at the picture, you can tell this is the wrong woman to get on the bad side of. She was risen in rank to Rear Admiral. She retired, came back into service, retired, came back into service, retired, and came back into service. And finally, when she retired for like the third time, 79 years old, she was the oldest commissioned officer in the Navy and was allowed to serve beyond mandatory retirement age by act of Congress. She had her PhD in mathematics. She created the first compiler, computer compiler, and the first compiled languages. She created the compiler and she was told it's useless. Computers can't do that. So she had to create a compiler language to run it and convince everybody that it would actually work, because they kept telling her, no, it won't work. No, it won't work. And so she and her decorations are listed there, the Presidential Medal of Freedom, aside from her military decorations. She wrote about going to a conference in civilian clothes at some point at a Navy station, and didn't like the way the Navy enlisted personnel were greeting the guests in front. So during break, she went back to her hotel room and put on her Rear Admiral's uniform and came back and explained to them how they should respectfully greet guests. And according to the rumors, at least, the service was greatly improved after Admiral Hopper had a talk with him. She also popularized the word debugging, and there's the bug. The first original computer bug was a moth that got trapped in the relays of an electromechanical computer that she was using. The moth was recovered from the relay, taped into the laboratory book. That book and the mummified moth are now in the collection of the Smithsonian. So you can actually go and see the very first computer bug, which comes from the work of Grace Hopper, in the Smithsonian. And there is a destroyer named after her, which was the first ship to be named after a Navy woman. There are a few ships named after women, but she had a destroyer named after her, first Navy woman to accomplish that task. Donna Strickland, she's one of the ones who won the half of the 2018 Nobel Prize in Physics. She was doing lasers, and I can't read all of my slides, so I can't remember just exactly what it was that she did to win the Nobel Prize for their method of generating high intensity, ultra short optical pulses. There we go. So one of the things that laser scientists are doing is illuminating chemical reactions that take place in 1,000th of a trillionth of a second. And now they're working on 1,000,000th of a trillionth of a second. So you need really, 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 really fast laser pulses to illuminate the chemical reaction so you can see what's going on. And that's the line of work this kind of laser pulsing is aimed to accomplish. And Frances Arnold also received half of the Nobel Prize in Chemistry in 2018 for her work in directed evolution of an enzyme, I guess. I can't read my own because I have to look behind my head. But she's the first woman to receive the Draper Prize, National Academy of Engineering, and she's currently a professor at Caltech. This was for a long, long time, for decades, there had been no women in chemistry or physics winning Nobel Prizes. And I managed to get these in. Andrea Ghez won the Nobel Prize in Physics in 2020, but I haven't had a chance to put her into the talk yet. And I have not updated this slide. So it only goes up to 2018. I have to do a little editing of my talk. But basically for physics, you can see the percentages. Women are a very small percentage of the Nobel Prizes. They're certainly not that small a percentage of the women who are working in the field. And they're certainly not that small a percentage of the women who probably deserve or did Nobel-worthy work, but there is still a strong tendency to just not give the prize to women for whatever reasons. Yes, Mariam Mirkazani, the first Iranian to receive the Fields Medal, the only woman and still, to the best of my knowledge, the Nobel Prize of Mathematics. It's given out every 4 years, but they give it to 4 people, so it's basically annual. And she received the prize in 2014 for her work on Riemann surfaces geometry. It's one of the areas that Ed Witten had worked on, and she's improved on Ed Witten's results, which is a pretty good trick because it's hard to improve on anything Ed Witten does. And there you are. That's my talk. It might have been a little bit better if I'd known more than 15 minutes in advance that I was going to do it. But as you can see, I tried to add some of the modern women. There's a lot of women that I didn't get a chance. And one of them was Cheng Wu, who was mentioned in the comments chat before I started the talk. She was actually at the University of California at Berkeley. She was offered a spot at Michigan, but didn't go because women were not allowed to enter the building through the front door. And so she went to Berkeley instead. And she's the one who experimentally verified theoretical prediction by two Chinese physicists, Li and I can't remember his colleague's name, non-conservation of parity in nuclear physics experiments. They crafted the theory. She proved it experimentally. They got the Nobel Prize. She didn't. It's another one of those scandalous examples of people doing things and not getting Nobel Prize. And of course, Jocelyn Bell, who is not in this lecture, is another example of the one who actually discovered the pulsars. But Tony Hewish, your boss, is the one who got the Nobel Prize for the discovery, even though his graduate student is the one who discovered it. And I guess I will let it go. Something peculiar is happening with my computer. Somebody's drawing curves on my slides. But I will bring it to an end and open it up for questions, I guess, if I can remember anything.
I have one, Tim.
Yeah.
You were talking about the fast laser pulses to illuminate fast chemical transactions.
Yeah.
Or reactions. What chemical reactions are that fast that they need to be illuminated?
Almost all of them are.
Really?
Yeah, I'm not a chemist, so there's a lot that I don't know about that. But the interatomic reaction where electrons bond, unbond, is extremely fast on most chemical reactions. There's undoubtedly slower reactions, but there's a lot of, I'm sure, biologically interesting reactions or complex reactions. They go by very fast. And so illuminating them with pulses like that allows you to actually watch the electronic transfer, things like that, to find out how it's a very fast process. And who knows? You start measuring things that are that fast, and like every other new thing you do in physics or chemistry, you discover something you didn't expect to discover.
Oh, never knew they were that fast.
I have a question.
Yeah.
Tim, in your estimation, given modern times, and that things are probably better for women, how do you feel currently things are for women? I mean, I know it's much better, but is there still a ways to go? And are there still examples of people who should have gotten more than they did?
Well, I think you're right. I mean, it certainly is. The situation is a lot better for women now. There are a lot more women in science. And just in my time at JPL, I saw a lot more women come into the science division and work in groups and teams where I was. I think the actual number of women in science has always been larger than you'd think, but they were never in advanced positions like team leaders, things like that. But you'll see a lot more of that now, especially at JPL. But examples like Andrea Ghez leading the team that discovered the black hole at the center of the galaxy. And
we saw that last month, I think, as well.
Yeah, and got her share of the Nobel Prize for that. And Wendy Friedman, of course, at Carnegie Observatories. I think it's better, but there's, of course, when you look at percentages like that on the Nobel Awards, there's so many, it's such a small fraction. You know, there are a great deal more women than that in science, and must be more women who deserve a share of the prize. But Nobel Prizes are really, shall we say, more politically correct in many ways than you might think. Not always awarded strictly by merit, by which I don't mean that the people who get Nobel Prizes don't deserve them, but a lot of people who do don't get them. And the committee knows they deserve one and deliberately doesn't give them one because there's something about them they don't like. So
Shocked.
they don't want to give
I'm completely shocked.
I'll bet.
Thank you, Tim. Wonderful presentation.
Oh, thank you.
All right, let me just interject. If you haven't signed up for the drawing for the door prizes, please do so. I'm going to close it out in a few minutes.
Alicia's my hero at JPL.
What's that?
Alicia's my hero at JPL.
Oh, yeah. Well, if
I
you want
lucked
to,
out.
if you want to ask, yeah, if you want to ask somebody about women at JPL, ask Alicia.
There you go.
Yeah, I lucked out. I ended
Maybe
up
we could
with
also
fantastic.
schedule someone to talk about African American scientists and things like that. Those would also be very interesting.
Yeah.
I think Stan Thompson had his hand up. Did you have a question, Stan?
No, I was applauding Tim's presentation.
Oh, okay.
Thank you.
I think everybody enjoyed it, Tim. Great job.
Thank you.
Great job.
Yeah, Tim, both thumbs up from the high country out here. Excellent
boy.
presentation.
Oh,
Is
thanks.
that the real Jack Eastman?
That's the real Jack Eastman.
Wow.
Can I
Jack,
take the fifth?
Jack, I used to be your neighbor at RTMC. I haven't seen you for years.
Yeah, it's too bad that Camp Oaks murdered RTMC. Sure.
In some ways, RTMC murdered RTMC.
Well, that's true, but the move from Memorial Day to be in competition with Okie Tex I think it was the kiss of death.
That's what I just said.
Yeah.
Anyways, I miss you and the Clark.
Yeah. Yeah. You know, the big Clarks had a little pup. End of last year, I picked up a 3.5 inch dated 1870. And
Okay.
superb
Well, contact me. I have $350 for it.
Yeah.
Jack is not selling one of his Clarks. Forget it.
The guy that I got it from said he got it at a flea market because it looked nice on his mantle. So I have no idea what he paid for it, but unfortunately for me, he did a lot of homework, got a hold of the Antique Telescope Society, and I think I paid a fair price for it. It wasn't
More than a few fleas.
Yeah, I was saying more than a sack full of fleas for sure.
So you want to tell us what we got for door prizes tonight?
Yeah, I've just reposted the link for the door prizes. I'm going to close it out. If you haven't, let me just repost it one more time, and then I'm going to close it out. And then,
What? There are door prizes?
oops, sorry, I just sent the wrong link. That was the link for the YouTube video. Somebody had asked for the link for the YouTube. I just sent that out.
I hope it's PG-13.
Well, considering the performance, maybe not. Hey, hang on one second.
Any other questions?
Well, this is Greg, Tim. I just wanted to thank you. It was a great presentation. I've studied a lot about the history of computer science, and I never even heard of Hopper writing the first compiler. I've got to go find a book on that. I'm really interested.
You wrote Fortran, right?
No,
I didn't. No, not Fortran. I think the language that she wrote was an ancestor of COBOL, something like that.
It was COBOL.
Algol, probably.
No, it was COBOL. It was COBOL.
No, okay.
But yeah, she was you're right. She was the mother or of modern compiler programming.
Yeah.
High level languages.
Yeah. She used to carry around a 1 foot long fiber optic cable. And when people asked her, how long is a nanosecond really? She would hold it up and say it's this long because the speed of light's roughly 1 foot per nanosecond.
I'm going to have to go find some sources to dig into that. That's really interesting.
Predates me.
All right, I've closed out the drawing now.
I like the bug story.
Yeah, I'm gonna have to. I've got to get that.
It's actually true.
I got to get that.
Bug
Where'd you get
shorted
that
something
slide?
out.
If you're ever in the Washington D.C. area, the Naval Weapons Lab in Dahlgren, Virginia, is where she had where she was stationed. That's where she found the computer bug, and I think there's a little museum there.
I had heard that story, but I always thought maybe it was a story.
No, there's a real moth.
Yeah, I saw the picture. I saw the piece of paper. That's freaking amazing.
Yeah.
That moth gave its all.
They've got everything in the Smithsonian, but they don't miss a lick.
Does anyone else have any more questions for Tim before we move on to door prizes, or are we good?
How can I be as smart as you?
You have to quit drinking and stop taking drugs.
Quit drinking, stop taking drugs, stop smoking, and start reading textbooks on theoretical physics.
Just need to take the right drugs.
There you go.
That's not going to happen, as you can see.
Okay.
Okay.
We're going to move on to door prizes now. Thank you, Tim, for a fantastic, inspiring talk. Thank you. All right.
Thank you.
Great job.
Thank you.
Bravo, Tim.
All right, Spencer, are you ready?
So, yep, I'm ready. So I got the names of all the people who've registered. I'm going to drop them into the spreadsheet. And then when I do we'll have drawings. There's a random generator that picks names at random and puts them in this column. So, Alicia, let me see. This is the first one.
Okay, so the first
Share your
person
screen.
is Am I sharing my screen? Oops.
No. Not yet.
Oh, okay, there you go.
What, you don't trust him?
So Kaz is the first winner.
All right, so Cass won a $25 Amazon gift card. Let me write down this person's name.
Okay.
Okay.
All right. Next one is Tony.
That would be me. Oh, first time at the meeting and I win something. Isn't that nice?
Perfect.
Woohoo.
All right, you won
Right.
an LAS website item. We have a
Excellent.
website where
Good for
we
you.
have a bunch of items for sale, but you get to pick one item for free.
I get the jacket.
The jackets are embroidered, but the long sleeve T-shirt that I got off the website is super great for astronomy too. It's cool, and the logo
My
is beautiful.
daughter-
They're black.
My daughter will be upset she did not join us. Thanks, guys.
Yeah,
Okay.
cool.
All right. Next one. Kenji.
Kenji won an LAS hat.
Yay, excellent. Thank you.
Okay. John Birbaum.
Actually, Alicia, can you? We got the hat last month, and my son is happily wearing it. So you can just put that back in. Actually, that's perfectly fine.
I can swap the two winning things and give you something else. Would you prefer that? Since you already have a hat?
You know, you can just. Why don't you just go ahead and draw another one? It's okay. I won since I won
Okay.
last month. Thank you.
Okay.
Oh, okay.
Is
All
John
right.
here?
I think he left. There's less people than were here before.
Okay. All right. Well.
Am I skipping him?
Yeah, we'll skip him.
Okay, so let's find someone else to win an LAS hat.
Okay.
Okay.
Stan Thompson.
I will gladly take a hat.
Okay, great. All right. Let's see.
Where did all these Thompsons come from?
How do we get so many Thompsons, Tim? What started that?
All right.
It's a
I'm in astronomy.
Jose
It's a ball.
Aguilar.
What did Jose win?
Jose keeps winning.
I know. I didn't win the last two times.
Jose won a $25 Amazon gift card.
All right.
Okay. Let's see.
I want the osprey behind you.
You can't have that now.
Okay. How many more do we go?
We have a ways to go.
Okay, Nasir.
Oh, here you go.
Nazir won a LAS website item.
Thanks.
Are you a huge airplane fan?
My late dad is, but I was too. I am too. Yeah, I go to air show, or I did before COVID.
All right, Annie Gross.
Annie.
Annie.
Hey, Annie.
Annie,
Annie, you there?
Yes, I am.
she won a LAS hat.
Oh, great.
All right.
All right.
Okay. Let's see. Where's Annie here?
Thanks, relax.
Okay. All right. David Jackerson.
Hey, David.
David won a red flashlight.
All right.
Oh, what?
A red flashlight.
Red flashlight.
We have two to give away, apparently.
Okay. Len.
Hey, thanks.
There. What'd Len win?
She also won a red flashlight.
I love it.
Okay.
All right, and the last one is for a laser.
All right. Let me see. Let me see where's.
Number 24.
Oh, here we go. Yeah. Andrea Scarlett.
Okay, Andrea
There's
just
Andrea.
won the laser.
Thank you so much.
Very cool.
Thank you.
You can use it to
Well
win a
done,
Nobel
all.
Prize.
All right,
All
so
right.
that completes the door prizes. So with that being said, are there any other updates that anyone wanted to give from the board, or are we good there? Board members, we good?
That it's fun being
Let's-
part of the group.
Okay, so
I have
All
a
right.
quick question that might have been asked before I got here. I had to go work tonight. Having to do with Lockwood. Do we have any idea when the restrictions on the groups are going to be lifted so we can get back to normality?
LOL.
yeah, we
Or-
talked about that earlier.
You did? Okay, I'll watch the recording tomorrow.
No,
Okay.
actually, I think we were talking about that before we started recording that. We were just talking about that before the meetings. Oh, no, I take that back.
Right.
No,
Mike
No,
talked
the
about
Lockwood
it during
update
that's right.
covered
Mark
all
talked
that,
about
so
that's
it's-
right.
We
I'm
did
sorry.
both. We did both.
Yeah.
There was my
I have-
rant and then the correct update.
I've got a very good feeling that after June 15th, everything is going to be cleared up, and I really think by July for sure, a lot of things are going to be opening up, and I'm hoping the planetarium will be. I don't know, but I just have a good feeling about that, and other places. So just
2021, right?
keep your fingers crossed. So we're getting there.
Yeah, I'm looking forward to hearing when Garvey might open again, so we get our Wednesday nights back.
There you go.
All right.
It'll happen. It's going to happen, I believe, by after June.
Okay. I'm going to adjourn the meeting now. If you want to stay to talk amongst yourselves, feel free to. But this meeting is now adjourned. So